Welcome to another video of the series Important Programming Questions to Know for Any Software Profile Interview. Here, we are going to see the pictorial algorithm and code for the Java program that will help us determine whether the input number is prime or not. Now, before proceeding, you might have this question that though I can find so many articles, so many websites on the internet that will give me the code for basic Java questions for any interview, why should I spend my time watching your video? And honestly, that's a valid question. Had I been at your place, I would have had the same question. To answer this thing very briefly, you can have look at the code, you can copy paste it and try to understand it at your level. But the intent here, or the aim here is, or the gap that we are trying to fill here is that we are not just here to share the code with you. No, we are here to help you understand the program, how to approach a program, and how to build your capacity to solve any programming problem in general, right? So, all in all, we are here to help you in developing that ability to solve a programming problem on your own without just mugging up the code, right? At least that is what we're trying to do. Cool. So if you have any questions, any queries, any improvements that you feel that this can be corrected in this manner for your better understanding, feel free to comment and we assure you to reach within 24 hours. Right. So let's start. And just one thing, I will be sharing the code of this particular program in the description. So need not rush about it while watching the video and copy pasting. No, just watch the video at peace and then refer to the code later on if required. Cool. Without wasting any more time, let's start. The first section says, what is a prime number? I know that you must be aware with what is a prime number, but I'm going to reiterate for better understanding. So in the first line, it says, what is common among numbers 2, 3, 5, 7, 11, and 13? And in the para, it says, they're completely divisible only by 1 and the number itself. So what is a prime number? A prime number is a number which is completely divisible only by 1 and the number itself, right? So for example, number 3. Number 3 is divisible only by 1 and 3, right? Number 5, starting from 1 up till 5, it is divisible only by 1 and 5. Number 4, starting from 1 up till 4, it is divisible by 1, 2, and 4. So it's not a prime number, right? All in all, you have to understand that a number which has only two factors, it's a prime number. And if it has more than two factors, it's not a prime number. Cool. And one thing that you should know, it's by definition that 0 and 1 by definition are not prime numbers, right? I'm not going to deep dive into this, why are they not prime numbers and all that, but you have to know one thing because this is important for the program, that 0 and 1 by definition are not prime numbers, right? Now let's go to the next section. In the next section, we are going to discuss the approach of how we are going to solve this problem, right? So first of all, let's go to the pointer number 1, which says, provide the number to check, I mean, decide the number to check for prime or not. So let's assume that we are going to take the number as 5, right? And I'll assign this number 5 to the variable, and the variable's name will be number to check, right? Simple till here. Now let's go to pointer number 2, which says, if number to check, that is the variable or the number 5 in this case, if 5 is completely divisible by numbers other than 1 and itself, then another variable, say counter, will increase by 1. I know this line in itself can be a bit daunting to understand given the point at which we are right now. Don't worry, when I'll be going into the pictorial algorithm, you'll be able to understand it better. But for now, understand there are two variables, number to check, and there is another variable counter. So if the number of factors is greater than 2, or if the number is completely divisible by numbers other than 1 in itself, then the counter will increase every time. This is what you understand for now, right? Now let's go to point number 3, which is more of a note. So this is something that you should know because it's an observation. And why are we discussing this observation? Because every program has to be optimized, so the execution time decreases, right? So let's say, I mean, when you see the line, you'll realize that anything greater than half of the number to check, that is 5, can never completely divide it. I'll reiterate. So half of 5 is 2, that which is 5 by 2, it is 2. Leave the remainder for now. In programming world, 5 divided by 2 is 2. 5 modular 2 is 1. This is something we'll see later on. But for now, if you divide 5 into half, then the number or the result will be 2. So it says the numbers which are greater than half of 5, which is 3 and 4, as you can see on the screen right now, they can never completely divide 5, right? So if we know, if we are sure that the numbers 3 and 4 will never be able to completely divide 5, why should we check for that, right? So we'll iterate or we'll loop only till n by 2, that is the number that we're taking, 5 divided by 2. This is the truth for all numbers. When we do this, the basic benefit is written in the last line, which says it reduces the complexity and execution time of the program, which is logical. One case number one is that it is going to check up till all the number n. That is, let's suppose if the number is 15 that we are checking, right? So it will check till 15. So the loop will go accordingly. But when I make it till 15 by 2, which is 7, right? So it will go only till 7. So the number of iterations will decrease and the number of counts will decrease, as a result of which the program speed and the execution will effectively improve, right? That is what the approach is. If you did not understand a lot in this approach, it's okay. This was just a introduction to what we are going to do. Now let's go ahead and let's go to the next section, wherein we'll be seeing the pictorial algorithm. This is the pictorial algorithm. For better understanding, I am going to show you this thing in general. So again, assuming that the number to check is 5 and the counter that we discussed, that which will increase every time it is divisible by any other number, is 0, right? First check, it says if the number is less than, I mean, if let's suppose if the number is 0 or 1, then the number is of course not prime, right? As we discussed in the definition, right? So first of all, the first check says that if the number to check is less than or equals to 1, then it is for sure that the number is not prime. Less than or equals to 1 means if it is 0 or 1, it's not a prime number, right? That is the first check, which is a bit less important. Now, second check is most important. Cool. So before going ahead and seeing the second check or the second validation, let me point you to this diagram on the screen, right? Which is, I mean, this is a typical division, and I am sure you must be wondering why are we seeing this? I saw this last in 10th or 11th standard. But yes, I'm just revisiting it, right? So this is the dividend, this is the divisor, this is the quotient, and this is the remainder. This is something that you should know. So in the second check, we are going to see the prime number with the help of division and everything. So I thought that I'll help you or I'll show you this diagram, right? So of course, when we have to check something again and again, as I've told you in previous videos, we use the loop concept or the iterations concept. So herein, we'll be using the for loop. And in the first iteration, it says for I is equals to 1. Of course, we'll start with 1, right? And I is less than or equals to 5 by 2. Why are we dividing it by 2? This is something that we discussed earlier. Because if we divide it by 2, the numbers greater than that will never completely divide. So we can ignore them, right? So if it says if number to check modular I, that is number to check is 5 modular 1, right? 5 modular 1, remainder is 0, right? This is the remainder. So modular basically gives you the remainder and division gives you the dividend. Oh, sorry, the quotient, right? Again, the quotient is given by the division symbol and the remainder is given by the modular symbol, right? Again, let's see the iteration number one more time. Iteration number 1 says for I is equals to 1 and I is less than or equals to number to check, that is 5 divided by 2, which is 2. So for I is equals to 1 and is 1 less than or equals to 2, it is. So let's see if the number to check, that is 5 modular 1. So 5 modular 1 is 0. If it is completely divisible by that number and if the remainder is 0, then increase the counter by 1. So counter earlier was 0, now it is 1. Right? Now again, let's go to the second iteration. In the second iteration, it will become I is equals to 2. Right? So now, is 2 less than or equals to 2? Of course it is, right? So let me go to the if condition that we discussed in the previous iteration. So 5 modulo 2 is not equals to 0, because if you keep 5 here and if you keep 2 here, it will be 2 2s are 4 and remainder will be 1, right? So it is not equals to 0. That is, the remainder is not equals to 0. So the counter will not increase by 1. So now also the counter remains 1. It's done, because if we go to for I equals to 3, 3 is not less than equals to 2, so the loop breaks, right? Now this is done. Now we have to print the result depending upon what we got, right? So it says, if the counter value, which is the variable that we took, if it is greater than 1, right, which is if it has more than two factors, that as I told you, if a number has factors other than 1 and itself, it's not a prime number, right? So it says if counter is greater than 1, then it's not a prime number, else it's a prime number. So that is what the algorithm is. That is how you approach a problem. That is how you create a mind map in your mind, and that is how you try to solve a programming problem in general, right? You have to take some variables in your mind, you have to think of the iterations, and then you think of the result, and then you code it out, right? So this is what the algorithm or the pictorial algorithm looks like. Now let's jump onto the code. Time to code. Of course, you see this code in front of you, but I am going to go into IDE and I'm going to show it to you step by step. So let me take you to, first of all, let me go ahead and delete the result that I already have. So we are in the IDE and we are going to go to it step by step, right? So we are going to take the number as 5, that is number_to_check, right? So I am adding some comments for better reference. So it says number_to_check for prime, and we have declared the variable as 5. Cool. Now let's go to the next step, wherein we'll be declaring the counter, as I told you, because it's important to check the number of factors a number has, and accordingly the prime number will be given. So let me go ahead and let me paste it here. The counter is 0 as we started. Then let me go ahead and let me take you to the first check that we discussed, if you remember, that we have to check if the number is less than or equals to 1. That is, if number is 0 or 1, then it's not a prime number. For sure, we need not go ahead, right? So you have this here. It says if the number to check is less than 1, which is 5 is less than 1, it's not. Then, I mean, had it been less than 1, had it been 0 and 1, it's not a prime number. We need not go ahead, right? Now comes the main check, which says, as we discussed in the algorithm, let's see it again line by line. For loop has been initiated with 1 and it says number to check is divided by 2, so it will only go up till the half of the number, right? And then it checks for the remainder. If the remainder is 0, that is, if it is completely dividing, the counter has to increase by 1, right? As I did discuss it in the pictorial algorithm. Now let's uh, code the print condition that we did in the last. So let me go ahead and let me show this to you. So it says if the if the counter value is greater than 1, then print the same as not prime, and vice versa, right? Again, if the counter value is greater than 1, that means that the number had more factors than 2. I mean, it was divisible by numbers other than 1 and itself, so it's not a prime number. And in the else condition, it says, of course, if it has only 2 factors, then it is a prime number, right? So let me go ahead and let me execute this program for you in front of the spectators or viewers, so for a better understanding. So it says 5 is a prime number, which is right. So let's check for other numbers as well. Let me check for 123. So I'll go ahead and I'll run it again, and let's see what the system says. It says 123 is not a prime number, right? Because 123 is divisible by 3. If you observe carefully, it is completely divisible by 3. So it's not a prime number. Now let me go ahead and let me put it as 1. So I'll put it as 1. It should say it's not a prime number because of the first check that we put, right? Now let me go ahead and let me put a number which is actually not a prime number. That is, it's a composite number, and let's see how it behaves then. So We have executed it and it says 8 is not a prime number. Now let me go ahead and let me put the last input, which is 11, and let me run it. So it says 11 is a prime number, right? So this is a handy code for you. If you ever want to check whether a number is prime or not, you have this. Of course, nobody is going to ask you in your project to print a program to check for a prime number. Of course, it's not. The intent here is to develop the approach of reaching any problem that you face in your project. So if you have some clear concepts about loops and everything which you can practice with such programs, you'll be better able to understand and solve practical problems that you encounter in the project, right? So that is all, and I hope that this video was helpful to you, and you were able to develop the ability to solve programming problems, and you'll be able to approach different programming problems going forward. So thank you so much for watching, and see you in the next video.